All right, we are finally here. We are on the cumulative portion of all we have learned about polynomials. We're going to put it all together and graph polynomials. So we're going to talk about zeros, multiplicities, leading term, intercepts, end behavior, and we're going to graph. I'm going to start with zeros and multiplicities for this, and let's talk. Let's do it. So we have the function f of x equals x squared times x minus 3 times x plus 3, quantity squared, and we want to graph it. The zeros, which again are the x-intercepts, and their multiplicities. Let's start there. From the function, we have the 0, x is equal to 0, x is equal to 3, and x is equal to negative 3. This guy, 0, the exponent is 2, so he has a multiplicity of 2. Even multiplicity means we are bouncing off of the x-axis. Remember, even multiplicities bounce off the x-axis. For 3, the multiplicity is 1. There is no exponent, so it's a secret 1, which means it's going to cross the x-axis. And it is not going to it's not going to wiggle. It's just going to cross 3 with no wiggle. And if that is a confusing statement to you, please go rewatch the multiplicities video where we talk about when does it wiggle, when does it not wiggle, when does it bounce. For this guy, the multiplicity is 2 because the exponent is 2, which means that it's going to bounce. It would have been better for me to write these zeros in order over here. I should have wrote it as negative 3, 0, and 3. And because I did this on an iPad, I have the ability to change that. Now they're in order. That's nice. I'm going to mark these on my graph and make note of them. So I have a 0 at negative 3, which means we have an x-intercept at negative 3. So that's right here. We have a x-intercept at 0. Oh, let me go ahead and plug her in. There we go. We have an x-intercept at 0. That's this guy, or it's in green, this guy. And we have an x-intercept at 3, right here. That's that 0. So all of those zeros tell me where we hit the x-axis. Let's look at leading term / end behavior. Leading term / end behavior. If you watch my end behavior video, you'll know what I'm doing to find this leading term. If you didn't watch my end behavior video to figure out what I'm doing here, then go watch my end behavior video. I will not be re-explaining it in this video. The leading term here, we have an x squared, an x, and an x squared. So that is going to come out to be x to the 5th. Right? The x squared from here, the x from here, and the x squared from there. So that is an odd degree, which means they go in opposite directions. the leading coefficient, which I will abbreviate as LC, the leading coefficient is positive. The leading coefficient is 1. So the leading coefficient being positive means that the right side, it's not that one, that one. It means the right side goes up. Odd degree means the end behavior goes in opposite directions. So I know that this graph is going to leave up this way. It's going to exit down this way. I also know how we move as we touch the zeros. I can fill out the rest of the graph right now. I want to finish by writing the y-intercept down, but we actually don't need the y-intercept because the y-intercept is 0. But let's write it down before graphing the rest of it. For the y-intercept, you just plug in x equal to 0 to the original function. So f of 0, which is going to give us our y value, this is 0 squared, 0 minus 3, 0 plus 3 squared, right? 0 times negative 3 times 9, it becomes 0. So there's a y-intercept at y equals 0. And that makes sense because if 0 is an x-intercept, then 0 is a y-intercept as well. So the y-intercept doesn't tell us anything here. But looking back to this function, we know we are bouncing at negative 3. So I'm going to come up to the graph, bounce, go down. At 0, I'm going to bounce again. So I'm going to go down and bounce. Then at 1, I'm going to cross with no wiggle. So I'm going to go down. Who cares how much? It doesn't matter. Boom, up like this. Now, is this going to be a perfect replica of the graph? No, that's not the purpose. The purpose is not to make a perfect graph here. It is to be able to talk about the general properties the graph has and give a good sketch of it. Not a perfect sketch, but a good sketch. Let's go ahead and do another one. And I am lazy, so I'm going to boop, 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 boop. I'm going to do this. Technology is wonderful. All right. The x-intercepts for this guy, the zeros for this guy. There's nothing from the negative 2. If there were an x here, we'd have x equal to 0 as an x-intercept, but we don't. So we start here. Remember, we're doing opposite signs. So if it says minus 4, we have 4. Plus 5 gives us negative 5. Plus 2 gives us negative 2. I'm going to write my zeros in order this time from the beginning. So we have negative 5, negative 2, and 4. So we have x minus 4 cubed. That means that the multiplicity is 3. Odd multiplicity means it's going to cross. And because the multiplicity is greater than 1, it's going to wiggle. For x plus 5, that gave us the 0, negative 5. And the multiplicity is 2. It's an even multiplicity, so we're going to bounce. For x plus 2, we got the 0, negative 2. The multiplicity is 1. So we're going to cross, and we are not going to wiggle because the multiplicity is 1. Odd multiplicities always cross. 1 has no wiggle. Everything else has a wiggle. All right, so I'm going to plot these. We have -5, 2, 3, 4, -5, -2, and 1, 2, 3, 4. For the leading term and the end behavior, I'm just going to write out the entire polynomial like I did in the video where I talked about this, where I talked about this in the end behavior video. We're not worrying about anything other than the highest power of x in each factor, so I'm getting rid of these. So I have -2, x cubed, x squared, and x. That comes out to -2 x to the 6th. If we add 3 plus 2 plus 1, we get 6. So the leading term is -2 x to the 6th. So we have a negative leading coefficient, which means we're going to go down when we go to the right. The multiplicity is even, so it goes in the same direction. Not multiplicity, the degree. Even degree, same direction. So if it goes down to the right, it'll go down to the left as well. Now I just have to use my x-intercepts and multiplicities and the y-intercept, which I still haven't done yet. Come here, Mr. Y-intercept. We need to plot a y-intercept here. This is, again, you're just plugging in x equals 0. So we have y equals -2, 0 minus 4 cubed, 0 plus 5 squared, 0 plus 2. This comes out to be 6,400, right? That's why there's no scale on here. So I'm just going to write 6,400 up here. All right. At -5, we bounce. So I'm going to come up, hit -5, bounce down. At -2, we cross, but there's no wiggle. So we go down and then cross. At 4, we have a multiplicity of 3, so we're going to cross and wiggle here. Now, before we get here, we have to hit the y-intercept. So I'm going to come up, I'm going to hit the y-intercept, come back down, and then I'm going to wiggle when I go through. Ready? Nope. Wiggle. I know it's a little bit, sorry. There's some noises happening outside my office that are interesting. I know it's a subtle wiggle, but it is a wiggle. I don't have any more patience than to draw it like that. A little bit of a wiggle, no wiggle. And that's the graph. All right, sometimes, let me grab this again, duplicate. You might be thinking to yourself, Professor could you not do that when the camera is off? Does it have to be in the video? And the answer to that question, my friend, is no. I'm tired, and this is the best I can do for you. you can watch me doing all the moving around. All right. Sometimes we have functions that aren't factored, and we are going to have to factor those in order to graph it. So looking at this guy here, the first thing I can do, I know that there's a GCF I can pull out here. There's a common factor of negative 5x squared that I can pull out. When I do, I get x squared plus 2x minus 25. No, not minus 25. Minus 15. And that quadratic factors into x plus 5 times x minus 3. That gives us the zeros 0, negative 5, and positive 3. The multiplicity on the negative 5 is 1. So it crosses with no wiggle. For 0, the multiplicity is 2, so it'll bounce. For 3, the multiplicity is 1, so it'll cross with no wiggle. One, 2, 3, 4, 5, 0, 3. The leading term is really nice when you have the polynomial in its long form, because there it is right out front. There's the leading term. I don't have to do much. Negative 5x to the 4th. That's a negative leading coefficient. So it's going to go down as it goes right. It's a 4th degree, which is an even number. Even degree means that the direction is the same for its end behavior. So I know that's my end behavior. Then when I go to draw my graphing, the y-intercept is super uninteresting. We already talked about what happens when you have an x-intercept of 0. If you have an x-intercept of 0, then you have a y-intercept of 0. And that's already drawn. It's right here. You just have to do this. Multiplicity is 1, so at negative 5, so we're going to cross with no wiggle. Cross. At 0, we're going to bounce. So we come down, we bounce. And then at 3, we cross with no wiggle. And I can put that in there and bam, that's our graph. So that's graphing. We're going to do a few silly problems here where we look at the graph and we answer some questions, but in general, the graphing portion where you construct a graph right by yourself, that's all there is to it. You look at the zeros, you look at their multiplicities, you decide whether they cross, and if they do cross, do they wiggle? And if it's an even multiplicity, we bounce. The leading term gives us our end behavior. You can find your y-intercept by plugging in x equals 0, and you have a full graph just off that information. So let's look at these graphs and answer some questions. These are pre-made graphs. And we're going to find the degree. Well, We'll determine if the degree is even or odd, if the leading coefficient is positive or negative, what the zeros and their multiplicities are, and write an equation for the polynomial. So, degree even or odd, well, the end behavior goes in opposite directions, right? Opposite directions. So that means that it is an odd degree polynomial. The right side goes up, which means that the leading coefficient is positive. What are the zeros and their multiplicities? Right, so the first zero happens right here at -2. So we have x equal to -2. It crosses through and there's no wiggle, so that has to be a multiplicity of 1. The next time we hit the x-axis is here at 0. At 0, we bounce. So the multiplicity has to be even. I'm just going to call it multiplicity 2. Right, because there's a bounce. Right here, we cross with no wiggle as well. That's at x equals 4. And finally, here at 6, same idea. We cross with no wiggle. So the multiplicity is 1. All this is asking is to write an equation for the polynomial. Just an equation for the polynomial. So we need the leading coefficient to be positive, which means just don't put a negative out front. Then we have our zeros and the multiplicities, so we just construct. For -2, the factor is x plus 2. The multiplicity is 1. So I'm going to leave it. The exponent is 1. For x equals 0, the multiplicity is 2. So if we have 0, it's like x minus 0 quantity squared. This guy's just going to come out front in the end. For 4, the multiplicity is 1. So we have x minus 4 with an exponent of 1. And for 6, we have a multiplicity of 1. So this is x minus 6, exponent of 1. I'm going to bring this x squared out front because that is traditionally what we do. And then I am writing all my other factors. This is one of the possible polynomials that it could be. Now, you could have put any positive number out front here. You could put a 7, a 9, a 20. Anything positive can come out front here if we wanted to, just for spice, because this is only an equation, not the equation of this polynomial. Let's look at this guy here. For the end behavior, it goes down as it goes to the right. So we know that the leading coefficient is negative. That also tells us when we go to write our equation that there needs to be a negative out here. So I'm just going to put it in. The end behavior goes in the same direction, which means the degree is even. At -1, we bounce. So I'm going to say the multiplicity is 2. At 2, we cross, but we wiggle. Cross with a wiggle. Cross with wiggle, which means that the multiplicity is 3 or 5 or, any odd multiplicity 3 or greater. And then we cross again here at 4. There's no wiggle, so this is x equals 4. Because there's no wiggle and we cross, it's multiplicity of 1. So putting this all together in an equation, we would have a negative because of the negative leading coefficient. This would be x plus 1, multiplicity is 2, x minus 2, multiplicity 3, and x minus 4, multiplicity of 1. And there it is. There is an equation for the polynomial. So that's graphing. It's really not that bad. I would go as far as to say it's even kind of fun. But it does take practice, and there are a lot of parts to put together. So please, if you haven't watched all the other videos, you came straight to this one because you're like, I just want to know how to graph. You got to watch those other videos for all of the pieces because I'm going through those pieces very, very quickly in this video. If you have questions, send me an email. Other than that, I hope your week is fantastic, and I will see you again in another video. Bye.